Hello, hello. Welcome back. We're going to talk about maximizing profit. So, in an economics or business class, you may have heard that profit is maximized when marginal cost and marginal revenue are equal. This is mostly true most of the time. Um, in general, we just have to kind of make sure it's really a maximum, but because it might technically be a minimum or neither, but in most situations it will be true. So, let's look at this with an example. Why do we know that there's a critical point for profit when marginal cost equals marginal revenue? Well, let's look at that. When is there a critical point for profit? Well, what is profit? Profit's what's left over from your revenue after you subtract out your costs. So, using what we know about calculus, we can take the derivative of profit and use the sum rule to say that's r prime minus c prime. Critical point is when p prime is 0. Well, what is r prime? What's the derivative of r? That's the marginal revenue. Derivative of c is the marginal cost. So you can see there's a critical point when this is the case. Add marginal cost to both sides. And you can see that there's indeed a critical point when marginal revenue equals marginal cost. So a lot of times, if you do want to find a critical point for profit, you can find it this way. Some people prefer just to find the critical point by finding this directly, just setting up your profit equation and finding the maximum of profit that way. But if you want to, you can use this fact to make it a little bit easier for you. Depends on how your brain works. Let's do example 4. A company sells Q ribbon winders. I don't really know what that is. They sell Q ribbon winders every year at P dollars per ribbon winder. And the demand function, thank goodness it gives us the demand function this time, is P equals 300 minus 0.02 Q. The ribbon winders cost $30. Okay, let's write that down. Cost is $30 each to manufacture. And we have fixed costs of $9,000 per year as well. Find the quantity where profit is maximized. So, profit is what we want to maximize. That's our objective function. And profit is revenue minus costs, always. We just have to figure out what's our revenue and what's our cost. Now notice that Q is how many we sell in a year. So let's do everything on an annual level. Let's find our cost equation. Our cost is going to depend on how many we sell. C is a function of Q. The cost depends on Q. We always have to pay that $9,000 in a year. We're also going to have to pay $30 for every ribbon winder we make. Good, now we have the cost. To get the profit, all we need is the revenue. The revenue of producing Q items, it's the same revenue we've been talking about all the time, right? Just how many are you selling and at what price? The price is just 300 minus 0.02 Q. Right? This is our price. So now we can find our profit. Our profit as a function of Q is the revenue minus the cost. The revenue, we can distribute that. The revenue is 300 Q minus 0.02 Q squared minus the cost. Be very careful to subtract out the entire cost equation. These parentheses are really important. That negative needs to get distributed. So our profit function is this. Let's simplify a little bit. 300Q minus 0.02Q squared. Distribute that negative. And you can simplify a little bit more by combining like terms. So our profit function is, let's write it in standard form. Plus 300Q minus 30Q. We only have 270 Qs now. And this is what we want to maximize. What's our domain? The numbers that make sense are we should produce. We can't produce negative numbers. And it's it's a very similar as before. This is a parabola. It opens down. We know the maximum will be at the vertex. We can either use the vertex formula or find when the tangent line has a slope of 0. That's going to be at the critical point. There's a lot of things we know here. Let's take the derivative. Negative 0.04Q plus 270. Critical point is when this derivative equals 0. Just a linear equation. Can solve that without too much trouble. 0.04Q is 270. Divide by 0.04 to get your answer. 270 divided by 0.04 is 6750. And remember, that's how many that we would be selling in a year. We already know that's a maximum because we know how profit functions and quadratics work. So we mostly just need to answer the question. Find the quantity where profits maximize. That's it. We should sell 6750 per year. And again, this is a perfectly valid answer, but the best answer would be to say we can charge this much, 300 minus 0.02Q. We can charge $165 for each of these. For an annual revenue or annual profit of, well, let's use our profit function. This guy right here. Negative 0.02 Q squared plus 270 Q minus 9,000. Annual profit is 902,000. Goodness gracious. I should get into the ribbon winding business. 902,250. Also, I didn't have to use such a complicated function, right? We could have used a different form of the function. Profit function up here. Could have done it in a couple different ways. You could use price. But there we go. Now let's make sure our answer makes sense. Again, this is, I guess, a really big ribbon winding business. It seems a little high. It costs $30 each to make one of these. So yeah, it makes sense that we're selling them for more than $30. It still seems expensive to me. I don't know much about the ribbon winding business. These numbers seem high to me. Makes me a little suspicious. But I'm pretty confident in my math, so I'm not worried too much. But yeah, that's the idea. And again, there was a little bit of annoying simplification over here for our profit. It probably would have been easier in this case to use the result that we got in the last one. There's a critical point for profit when marginal cost equals marginal revenue. Then we could have just said, okay, what is marginal cost? That's just 30. The derivative of cost. Marginal revenue is just the derivative of this function, which is just 300 minus 0.04. Notice that if we set marginal cost equal to marginal revenue, all of these steps would have gone much faster. So all we needed to do was set these two things equal to each other. All right. So instead of simplifying a profit equation like I did here, remember I said you can do it either way? A lot of times it is faster. You just set marginal cost equal to marginal revenue. But remember why that's the case, right? If you just plug something in, it's not going to be easy to remember, and it's not going to really make a lot of sense. But if you can understand why we care about when marginal cost equals marginal revenue, it's just the critical point for a profit function, then it's going to be much easier to remember and will make a lot more sense when you use it. So that's kind of the point of this video. Let me know if you have any questions about it, and so long.